Welcome back, computer science students. So in this video lecture, we're going to continue our topic of interfaces, and specifically we're going to talk about why you would want to create your own interface. We spent a lot of time talking about how you implement interfaces, specifically the comparable interface, but now we're going to talk about writing our own, why you might want to do it, what it does, what you can and cannot do. And I think you'll find that writing interfaces is actually pretty simple. So to start, we're gonna kind of shift gears. We're still in the same tester class, but we're gonna shift gears and focus on the square, hexagon, and dodecagon class that are available to you. So the problem is we've created these square, hexagon, and dodecagon classes. If you take a peek at them, you'll see that their goal here is they basically are all really simple. They have a side length, and from that side length they calculate an area. And you can do this, you can just look the formulas up online and see that I've typed them in. But that's essentially the idea here. So they all have really similar methods, they do really, really similar things, but they have different formulas. And so, that kind of, if you think about this structurally, it seems like we could have like a superclass, like a polygon superclass that all these inherit from, and they all maybe overwrite the get area method. Because what we really want to do is be able to make an array list of polygons and be able to add whatever kind of polygon we want and then run it through a method here at the bottom. I'm going to uncomment it. If you follow through our code, it'll start off commented, but I'm going to uncomment it. There's an error because it's looking for a polygon, but we don't have a polygon imported yet. And so there's a few different suggestions. We're going to end up creating an interface for Polygon, but not quite yet. And so first I want to talk about the actual why we're going to do an interface and not a class. And the reason is if we made a superclass called Polygon, then we could kind of, there are ways we could force it to not be able to, you could make a private constructor to make it so objects can't be created, but really an interface is appropriate for this because we have a thing that needs to be done and performed across 3 different classes, but the superclass shouldn't really exist. And what do I mean by that? we really shouldn't be able to make a polygon object because what we're doing with polygons is trying to be able to define their area, to get their area. But if you do a polygon, how the heck do you know what the area is going to be? A polygon could be anything. It could be even like, I'm doing regular shapes. So hexagon, regular dodecagon, square, which is easy. How do you calculate the area of like a star? If I did, if I drew a star, this is a polygon. Well, how do you, the area calculation is going to be very different than the area calculation for a bunch of different things. For a bunch of different other types of polygons. So you can't really make one rule for what is a polygon shape area calculated, or how is it calculated. So we don't really want to make a polygon shape. We want it to exist so that we can have an array list of polygons and pass them into a method so we can calculate their areas, but we don't want to actually have polygons themselves. We actually don't want to be able to create those objects. We only want to be able to create squares, hexagons, and dodecagons and treat them as polygons. So in this case, interfaces are really helpful. So we're going to make an interface. Now I'm going to show you a couple ways to do it. The first one, we could technically make it as a class and then rewrite it, but the nicer way is if you right-click on your project or your source folder, and you go to New, and you click Interface, it will let you create your interface. So we're going to create our Polygon interface. And so the idea behind an interface is you have some common thing that multiple other classes or several other classes need to be able to do, but you can't really define it until you get down into those specific classes. So I want to be able to get the area of my polygon, but I can't define how until I know which kind of polygon I am. And so what we would do is, and this is the really cool part about interfaces, is they're really easy. We would simply define the method, public double get area, open close parentheses, semicolon. In this case, for this problem, this is our whole interface. And in fact, no matter which problem you create it for, all this interface is going to have is definitions, method definitions, not implementation, not details. You should never see, if statements and loops and other types of code in an interface. Instead, it just creates an interface. It creates a way to define that this getArea method is going to exist for every polygon. There's going to be some way that we're going to calculate it. And if you create a polygon and you implement the polygon interface, you must have a public double getArea method. In fact, if I comment this out, we're going to have an error now. So this is one part of interfaces. Once you have defined a method in an interface, if a class implements it, it must provide the implementation, right? Implements interface must provide implementation for the methods in the interface. So I must implement or provide code for how do I find the area of a square. Now, fortunately, I've already written these classes nicely, so all we have to add is implements polygon, implements polygon. Okay, and so now my square class, hexagon class, and dodecagon class all implement polygon. So that's all the setup. We have an interface polygon, defines a getArea method. All the classes that we want to be able to treat as polygons have to implement polygon, implements polygon, and they have to provide an implementation, actual code that provides actual results for the methods defined in the polygon interface. So that's it. That's the idea here. Polygon interface has a getArea, therefore square, hexagon, and dodecagon, which now implement polygon, must also have getArea and must provide the implementation details, the parts in curly braces here. So now that we've done this, we can make an array list of polygons. Maybe array list of polygon, my polygons equals new array list of polygon. So we have an array list that holds polygons, which is fine. And then when I add them, I can add a new square, maybe with a side length of 2, so we can do the math real easy. We can do my polygons dot add a new hexagon, and the equation here is going to be hard anyways, so we can just type in a number and check it later on Google. And then my polygons dot add new dodecagon, and since it has 12 sides, we'll make each side length 12. And note, these are actually doubles, so I could do, well, for the other ones that are not easy to calculate, let's do more complicated numbers. And so we can add in a square, hexagon, and dodecagon to our polygon array list. So this is kind of the idea of inheritance, of polymorphism. The difference is, one big difference, one really key difference, is that when it comes to interfaces, since you didn't implement anything in the polygon class, you can't actually create a polygon. You cannot instantiate the type polygon. Polygon's an interface. You can't create a polygon object. So that's one really key difference. And conceptually, it's oftentimes why you make the difference between a superclass versus an interface, is because you really wouldn't want to create an object from the interface. We wouldn't want to actually create a polygon, because who knows how you calculate the area. You know how to calculate the area of a square, a hexagon, and a dodecagon, and you want to be able to treat them as polygons, so that way you can, call methods that take polygons or add them to array lists that hold polygons, but actually allow them to define how their area is calculated. So now if we do something like for int I equals 0, I less than my polygons dot size I plus plus, we can use our print polygon method to print my polygons dot get I. And we got to make sure we spell it right. Polygons. There we go. All right. So if I run this, we can see my shapes area and I had to be a little generic. There's ways to get around this. We could have, well, there's a number of different ways we could get around this and have it say squares area and provide more details here. But for quick reference here, square area is 4.0. Hexagon calculated completely differently. Dodecagon calculated completely differently. You can check these online if you'd like to. Try different numbers, check different things. But this is what interfaces let us do. We can write our own interface, which again, they're really simple. Public interface, give it the name of the interface, and all it does is provide method definition or method headers or method definitions. Same thing. But the implementation, the code that actually goes inside, is implemented by the classes that implement the interface. And that allows us to take advantage of these inheritance-like and polymorphism-like things, like creating an array list of polygons and calling a method that takes only polygons, but also does not allow us to actually create a polygon object. So it's really useful in a lot of different ways, and hopefully this demo gave you an idea about how it's used. Like I said, the polygon interface and using interfaces here is very handy. It's also very easy. Interfaces should always be easy code. It's just definitions, no implementation. And so all you have to know is what method definitions we need, and you add them in. So I will see you guys next time for the next topic.